In order to derive better intuition for the properties of these oligopolistic markets, we're going to solve a concrete example, which is the case of linear aggregate demand and two identical firms. In particular, we're going to suppose again that there are two firms and that each one of them has a cost function, C of Qi, which is simply given by mu Q. It's constant returns to scale, and mu is the marginal cost, which is the same for both firms. Also assume that the inverse aggregate demand function for the sum of the two firms produced is equal to P max minus M of Q1 plus Q2. Okay? Now, what is the demand faced by firm I? Well, it's going to be this inverse demand function taking the quantity of the other firm as given, which is going to be P max minus M of Qj. And again, this is the behavior by the other firm. And then minus MQi. That is the demand function, or the inverse demand function, faced by firm I. And what is it going to do? It's going to maximize over Qi greater or equal than 0, that demand function times Qi minus its marginal minus total cost, which is MQi. Now that's a problem that you know how to solve if you think of this as a constant, because it looks like the monopoly problem, except that the intercept of the demand function has shifted to that, and we know that that problem is going to have marginal revenue for I given Qj equals to marginal cost for I. And this is going to be equal to P max minus MQj, that's the intercept that firm I is facing, minus 2MQi equals to mu. Okay? Now, the key to solve the problem is to notice that since the two firms are identical, we're going to have a symmetric equilibrium. Identical firms imply a symmetric equilibrium in which Qi equals Qj, and let me call that Q oligopoly. So that implies that that equation has to hold with P max minus, substituting this there, 3M Q oligopoly equals mu, which implies that the equilibrium quantity of the oligopoly is equal to P max minus mu divided by 3M. Now let's look at the nature, the graphical nature of the solution, and use it to compute the amount of inefficiency or deadweight loss produced by having an oligopolistic market instead of perfect competition. So let's do our usual diagram first, in which we're going to draw the inverse aggregate demand function for the market. So this is for the market, and the marginal cost function for the firms, which is equals to to mu. And we know that at a competitive equilibrium, we're going to get this level of quantity, which is optimal. And you should be able to compute this given what you have learned in previous lessons. This is P max minus mu. I'm not going to do it again, divided by M. That's the optimal total production in the market given the parameters of the market. Of course, that's not what the oligopolistic market is generating. What the oligopolistic market generates is something like this. Let's say that every firm is producing QL, and therefore for a typical firm I, the demand that I faces, given that the other firm is producing QL, looks something like this. That leads to a marginal revenue curve that kind of looks like this. As a function of Qi, given that the other firm is producing QL, the best response by this firm is, of course, to produce Q oligopoly by either of them. That leads to a total output in the market. So this is, so let me improve the writing here. 2QOL is total output in the market, and that leads to this equilibrium price. that I'm going to denote by P oligopoly. Okay, and you can obtain the formula for that price oligopoly by substituting the value of, I keep writing this very poorly, 2QOL, the value of the total output in the inverse demand function, and what you get is 2/3 of mu plus 1/3 of P max. Notice something interesting. In a competitive equilibrium, the price would have been P star equals mu. Here the price is shifted a little bit towards this value, P max, and so it's therefore higher than would have been in a competitive equilibrium. Now, what's the deadweight loss in this market? Well, we know this is the total amount produced, this is the optimal amount, so it's going to be this area. Is the area between the inverse aggregate demand function, which is also the aggregate marginal benefit curve, and the marginal cost curve, which is also the aggregate marginal cost curve, and the underproduction and the quantity produced. So this is the deadweight loss. Now let's compute what the deadweight loss is. That deadweight loss, I'm going to do it on the right hand side, is going to be equal to 1/2, because it's a triangle, the optimal quantity minus the 2QOL, which is the amount of the quantity generated by the oligopoly, and that's the base of the triangle times the height of the triangle, which is the price of the oligopoly minus this price in equilibrium. And this is basically going to be 1/2 of 2/3 m P max minus mu. I'm just substituting terms. And this other one is going to be 1/3 of P max minus mu, which is going to be equal to P max minus mu square divided by 9m. So there is a positive deadweight loss, and it tells you how it relates to the different parameters of the economy. Now let's do a distribution and analysis of the surplus generated by this market. What I have done here is I have redrawn for you the key features that we need for the analysis are the aggregate inverse demand function, the marginal cost function, the equilibrium price in the oligopoly, the total quantity produced by the oligopoly market, the equilibrium price in a competitive market, and the intercept of the aggregate demand function. And what we want to do is we want to compare what happens to producer surplus, consumer surplus, and social surplus in the perfect competitive case and the oligopoly case. And let's be precise about the experiment. What we're comparing here is what actually happens when there are two firms, these two identical firms in this example, and we run an oligopoly market. Well, what would have happened, so this is a counterfactual, if these firms had behaved competitively. So we know that if the firms had behaved competitively, this would have been the equilibrium price, this would have been the quantity produced, and the consumer surplus would have been A plus B plus C. With this constant returns to scale production function, we know that producer surplus is 0, there are no profits, and social surplus is A plus B plus C. With oligopoly, the consumer surplus, because they have to buy at this price and only buy this quantity, is going to be A. The producer surplus is going to be B. Social surplus is going to be A plus B, and there is going to be, let's do the difference here, a Z, which is the deadweight loss. And notice that producer surplus goes up by B, and consumer surplus goes down by minus B plus C. So not only do we have a transfer to producers, we have a loss of social surplus.